What if, within the vastness of the universe, there exist regions where, the moment you cross a boundary, the entire field landscape shifts, almost as if you've stepped from one world into a completely different one, where the laws of nature and the structure of space itself feel utterly different? In the energy filament theory, this idea might seem like something straight out of science fiction, but it's actually embedded in many serious theoretical models. Though, at present, there is still very limited direct evidence to support it. Let's start with a simple analogy. Imagine a large steel plate being subjected to pressure. Under normal circumstances, the energy sea would gradually smooth out the stress across the surface. But if the plate is pressed too quickly or cooled too fast, it might crack and form a fault line. On either side of the crack, the plate remains stable. But right along that fault line, the texture of the plate abruptly breaks, and the direction of the material changes. The fields in the universe could work in a similar way. During the extreme early stages of the universe, the tension fields and various texture fields should have merged into a unified pattern. However, if certain regions froze while others continued to evolve, this could leave behind unique field fault lines. One possible remnant of this phenomenon is what's called a topological defect. Imagine the energy sea failing to smooth out a crease in the field, leaving behind line-like field wrinkles. Think of them as cosmic strings, or large areas where the field orientations on either side are completely different from each other, separated by a thin domain wall. In the language of the energy filament theory, we can think of this as a style boundary in the field, where the field on one side speaks a completely different language than the field on the other. If you were to move from one side of this boundary to the other, you might encounter strange phenomena such as unusual gravitational lensing patterns, unexpected polarization signatures, or even subtle, structured differences in certain physical constants on cosmological scales. Of course, these ideas are still just theoretical possibilities and are far from being proven by observational data. A less extreme version of this concept could be large-scale filamentous structures and field bands in the universe. While the universe at large remains roughly uniform, on extraordinarily large scales, the tension and texture of the field might still break up into climate zones of sorts. Some regions could favor the formation of black hole structures, while others might experience slightly tighter field tension. Some areas could exhibit large-scale magnetic field patterns that are more uniform and consistent than others. You could think of this as climatic zones within the field of the universe. The truly extreme boundaries, where crossing from one side to the other would feel like stepping into an entirely different physical realm, is still a speculative idea with no direct observational evidence to support it. So, does the universe have boundaries where the field completely changes its language on either side? From the perspective of the energy filament theory, while it's not impossible based on the underlying mechanisms, we would need extremely robust observational evidence to consider it as a real phenomenon. Right now, this idea remains purely theoretical, far from being a concrete reality. It's more of a reminder to us. When we look at the grand scale of the universe, we might want to consider that the field landscape we know and understand could be just one regional style within the broader energy sea, and not necessarily the only one that exists. Tap follow, share it on New Physics, Clear Universe.